Hello everyone and welcome to the 16th webinar in AWC3's webinar series about watercourse crossings. My name is Daniel Monaco and I'll be acting as host for today's webinar. Before getting into the webinar, I just want to give a brief introduction to AWC3 in case this is the first webinar you're attending in the series. So AWC3 is the Alberta Watercourse Crossing Collaborative. It's a not-for-profit organization whose primary objective is to facilitate information transfer around the issue of watercourse crossings in Alberta and their impact on native fish species. So that's what this webinar series is all about, is sharing information from subject matter experts and trying to get that information out to as many people as possible. Since we've received some questions about this, I want to let everybody know that this webinar can be used for continuing competency credits for professional associations. It counts as a half hour of credits and has been approved by most major professional associations. So if that is something you're hoping to take advantage of, make sure that you keep your receipts and your registration confirmation email. If you have any questions about this, you can email us at info@awccc.ca. Today's webinar is about driving a cultural shift through the use of resource infrastructure standard specifications. And we have Cody Ponting from SureSpan Construction with us as a presenter. To give a bit of a background on today's presenter, as Vice President of Resource Infrastructure at SureSpan, Cody is involved in construction projects at all phases, from preliminary costing to contract closeout. Cody has 10 years of experience with centralized focus on resource and industrial infrastructure, including remote and limited access design build projects in mining, forestry, and oil and gas sectors. Cody also oversees niche and specialized construction projects which demand innovative construction solutions. With a Bachelor of Science in Biology and Master of Business Administration specializing in management of growing enterprise, Cody understands the need to have a long-term view of the resource sector. So before passing things off to Cody, if anyone has any questions throughout the webinar, you can submit those through the GoToWebinar toolbar on the right-hand side of your screen. I'll be compiling those questions and we'll get to them once the presentation is done. I just want to ask that everybody keeps the questions directly relevant to the presentation topic so that our presenter can answer those to the best of his ability. So without further ado, I'll pass things off to Cody.
Hey guys, thanks for joining us here today. Thanks to Daniel and Bruce for the invite to present at this webinar. Today's topic, today's discussion, today's webinar, wordy title, driving a cultural shift through the use of resource infrastructure standards. Hopefully we can all figure out what that means as this goes, myself included. Introduction, no need for an introduction, just a bunch of titles and education that would trick you into thinking I know what I talk about. Daniel, I appreciate you calling me a subject matter expert, because at the end of the day, I think as contractors, we just see ourselves as dumb bridge builders, but much appreciated. So, I mean, the most common question I get when I get asked to come to a bridge site is, what do I need here? What do you need to build? You know, maybe a washed out culvert, it may be some failing infrastructure, it may be a complete greenfield site. A client, an asset owner, stakeholder says, well, what do I need to build? You know, unfortunately, in the world of construction and bridge building, there is no Google answer to what bridge do I need. If only there was. It would make my life easier, probably make it less profitable, but it would make engineers' lives easier. I guess we could say that there'd be the WebMD syndrome, where you'd have a client who thinks they know what they need, and the reality is they actually don't, but that's not a discussion we'll have today. So let's jump into this. What this presentation is not, guys, I'm not an expert on regulatory issues, approvals, processes. I'm not going to talk to that, mainly because I don't want to be called out for it during the Q&A period, because I don't have a clue what I'm talking about. It's not a call for the change to the current code of practice. I think Steve Acorn discussed last week best management practices. These best management practices are in place for a reason. I think, you know, as contractors, consultants, clients, we are diligent in everything we do. We do try and put our best product forward. We try to manage those practices in a means that's environmentally respectable and manageable. What I do hope to accomplish today is just rally everybody around a conversation or the necessity for a standard set of bridge specifications at the resource level, because I think by and large it's lacking in the Alberta resource sector. This isn't a comparison or a BC trumps Alberta scenario. I see some things on both sides of the border, some that can be transferred from BC to Alberta, and of course some that can be transferred to Alberta to BC. But this particular day, I want to talk about what this standard set of specifications could look like and how it could help us as industry experts to progress water crossings in Alberta for the better, of course. This presentation at a glance, really what it is what do we have now? What resources are available to us as experts? Kind of threefold what we have now, I would say. We have the Alberta Transportation Standard Spec, which I'll get into in a sec. We have precedents and past knowledge. Us as industry experts, however many years we've been here, I view myself as on the younger side of that. No disrespect to anybody at the tail end of their career. We have precedents and past knowledge. Oftentimes we take what we know or what we did in the past and try and apply it to what we're doing in the future. And then of course on the client side of things, they got their pocketbook. So that's kind of the three pieces to determine what we need to build a bridge in the resource sector today. Does it work? I mean, of course it works. We've built how much infrastructure already? I mean, you can drive around any resource road, any range road in Alberta, and there's X amount of crossings in any given time. Is it the best path forward? Is it modern? Is it evolving for the better? I would like to think yes, but there's always room for improvement. So my hope is that through this conversation, through this development of standard specifications, we develop this path forward and essentially standardize the industry thought process around what bridge crossing should look like. You know, and hopefully even recognize some cost savings at all levels in industry at the end of the day. So what is the current approach to deciding what you need for a bridge? If we were just focusing on the Alberta Transportation Standard Specification, the same standard specification applies to a highway bridge as it does a resource or an industrial bridge. That being said, you got 463 pages. Someone's probably going to call me out for that number, but that's fine. 463 pages of standard specification. What happens when you have a small crossing, 4 or 5 meters? Do you honestly think that the stakeholder, sure they aren't held to a certain standard, maybe their corporate branding isn't on the forefront of all developments. Do you think that that individual is going to take that 463 pages of standard specification and roll it out into their crossing? I use the two pictures here as an example. On the left, you have a rural, essentially a resource infrastructure bridge, which kind of looks like the aqueducts of Rome. There's an extensive amount of concrete work in that for a bridge that maybe sees 10 vehicles a day. Of course, the other extreme, the photo on the right, you have, which I'm sure whoever installed it thought they were brilliant, or whoever came up with the idea thought they were brilliant because they were able to use some old lock blocks and a concrete slab that they had lying around as a wash pad, I'm guessing. Zero way to refine that 463 pages down into something that works for essentially not only the farmer, but us as industry experts as well. So again, back to my original comment. Why is it that the Alberta Transportation Standard Specification, the same code, the same standard, the same set of designs or design parameters is used on a $100 million highways bridge as it would be expected on a $100,000 resource bridge? And we see it all too often. You look at any general notes section of a resource bridge drawing and you'll see reference to the Alberta transportation specifications for bridge constructions. Now, let's not say there's not some good content in there, because there is. You got to search for it though, you know, and I'll hope to talk further on in this webinar about, you know, taking some of that information, taking the good bits and pieces and refining that down to something that can be used at our level in the resource sector. You know, what's the cost of using this Alberta Transportation Standard specification at the resource level? If you look at it and you take cost on average, and again, I'm sure some of you might disagree with these numbers, but this is just a quick historical search through tenders that I've lost in the last couple months. The average cost for municipal highways bridge, for that matter, in Alberta ranges from $7,500 to $9,000 a lineal foot. Caveat. On the resource side of things, that number comes down not significantly, $4,500 to $5,500 per lineal foot to construct a resource style bridge. Now that is supply and install, and that's not including the 40-foot bridge that you had left over from 3 years ago in the boneyard that you put a new wear deck on. This is new construction at the resource infrastructure level, supplied, installed to this Alberta Transportation Standard spec. And of course, what happens if you don't have that $4,500 to $5,500 a lineal foot to float? It's almost it's not a plague in our industry, but it's a blemish on our industry. When you don't have the capital, you often find yourselves doing the quick fix. And unfortunately, the quick fix all too often isn't the right fix. I'll take this bridge for an example. Client didn't have enough funds to replace the structure. Didn't even have enough funds to test the steel for that matter, but the solution was a redeck. No timelines on when they were going to replace that bridge. Just they figured a redeck would work. It would be aesthetically pleasing, and hopefully they would retire before this bridge became a future problem. So how do we improve on this as industry professionals? What do we take away from this? What do we take from that Alberta standard specification? What do we take from what we know? What do we take from each other and refine it down into a smaller package, something we can quickly reference to understand what we need in the field at any given time? And again, I said I'm not going to stack up the flaws of BC and flaws of Alberta and compare the two. But what BC does have and what is used practically every day is a Forest Service Bridge Design and Construction Manual, or it's a BC Ministry of Forests standard set of specifications. This is a complete drawing set at the resource level that defines the parameters to install these industrial bridges or these industrial infrastructure. Very easy to use, very quick to reference, and an overall effective tool, to my understanding. How is it effective? I mean, it's seen from a monetary stance alone. The average cost of a resource bridge in BC, $2,900 to $4,200 a linear foot. On the worst scale, it is still cheaper to build a resource bridge in BC than it is in Alberta. Why? I'm gonna ignore the macro factors here for a second, and obviously there's some geotechnical issues and a whole bunch of other things. But at the end of the day, I would argue that by and large, the use of this standard specification helps drive everything from the engineering level to a level of comfort with the fabricator, to a level of comfort with the contractor to know what they're going to build on any given day. At the resource side of things in Alberta, it's often, what do I have? How can I make this work? What can I take, knowing what I know in BC and try and apply it to this? But for whatever reason that may be, the cost at the end of the day always comes out heavier on the side, or on the eastern side of the Rockies. So where do we start? How do we take what we have, refine it down, still take away those key components, and come up with a standard set of drawings that applies at the Alberta level? Arguably, it's quite simple. We take what we have. We streamline the existing standards. We choose the concepts that work for us. We choose design concepts that are practical to the client's pocketbook, practical from an engineering perspective, and we modify these with constructability in mind. What sort of equipment are we using in the Alberta resource world? Who as contractors are available out there? And essentially try and almost dumb it down so it's opening up the playing field to all contractors, all consultants. Anybody can read these standard specs and apply it to their potential crossing. And that in itself is the basis of where I think we should start with this. Take what we have, take that Alberta standard specification, pick out the pieces that are good, pick out the pieces that apply to what we do, take out the galvanized W-beam guardrail brackets, the stuff that no one's going to look at, page 263 of the standard specs. Take that junk out. What do we need? Let's simplify it. Let's apply it. Let's do this on a practical level now. Okay, how can we use this standard design, or let's assume for a sec we have a standard set of designs. How do we use this at an everyday level? So we'll run through a little example here. We show up, myself, a client, show up to a crossing. This particular picture, it's I think they're about 1,200 mil culverts in a row. Obviously, there's some problems there that I'm sure some hydrotechnical guys will pick up on. But we look at this. Okay, the obvious solution is we need a bridge. We got to open up that water course, take the drainage from the left side of the road, open it up, allow it to drain freely to the right side of the road. In my eyes, this is a short span crossing. And will differ from short span to long span, put the cutoff at around 90 feet. So this is a short span crossing. What is it? Is it a permanent or a temporary crossing? For the most part, it should be a permanent crossing. Another flaw in our industry is attempting to throw in temporary crossings. And sure enough, temporary crossing becomes a 20-year, 30-year crossing. Someone retires and it's someone else's temporary problem 30 years later. So through this standard spec, through this standard design, you would have quick reference, short span, large span. In this particular instant, we recognize the fact that we need a permanent bridge. Now, what sort of bridge you need after that? My hope is that the engineers, the consultants that you hire would come in and attempt to guide your decision on whether you need a slab bridge or a composite bridge. I mean, that at the end of the day comes down to dollars, clients, pocketbook, what's available to us as builders. You can take the same set of standard specifications. What do you need as a substructure? I mean, all too often, Alberta, we're going to resort to driven piles every time. There's a few licensees, woodlot owners, asset owners at the oil and gas level who recognize that some slab footings are now available to use. So you pull up your standard set of specifications and realize, okay, what size bridge do I have? Quick reference, what size piles may I need? Or alternatively, what size slab footing do I need based off my loading requirements, my design vehicles, my bridge width, so on and so forth. And again, I'm going to jump back to the BC Ministry of Forest Standard specification. Within the first 3 pages of this, you can establish those 2 things, the type of bridge you have, the type of footings you need. Now you're just saying, oh, what type of footing do I need? Is it that slab footing? The BC Ministry of Forest Standard specs is a beautiful thing because it lays this out perfectly for you. You go in there, recognize your load ratings. You have footing sizes identified right there. You have a footing type identified right there. You have your max min dimensions. Myself as a contractor, I can look at this, figure out what I need, figure out a material quantity, and without soliciting pricing from various fabricators, I can get my pricing within relatively close to what the material cost is actually going to be on this bridge. The same is applied to piles. If we did decide that piles were the best method, I mean, of course, we would rely on a geotechnical expert to guide us in this decision, but we know what size piles we need. We can do quantity takeoffs based on that. And all this information is right there. It's at hand. So why go through all this effort? Why are we as industry professionals going to collaborate and come up with an industry standard set of specifications that works for all of us? Is the benefit there? Is it worth our time, taken out of our days, and trying to make a dollar to come up with what's better that someone else can use later on. I mean, that's kind of a trite response, but why the effort? As asset owners and contractors like myself, builders, it provides us with the framework to conceptualize our own crossings. We don't have to phone the engineer on day one to get him out there to take a look at this. With this standard set of specifications, we can go out there and say, okay, with the tape, hip chain, whatever you have, I need a short span here. What type of footing? Well, phone the geotechnical engineer, kick the dirt around. Maybe you'll figure that out pretty soon. It also gives us the background to question third-party designs, potentially decreasing cost. I use this all the time in BC. Depending on the engineer consultants, some have experience at the resource level, often others do not. And for those that do not, we see a trend to over-design that by which is needed on the crossing. And having this framework allows you as an asset owner or a contractor to potentially question this and raise the question of potential value engineering in the structure itself. Could be an easy example. You show up at a crossing, and engineers over-design the pile size. You pull up this quick reference, say, well, why not decrease the pile size? The standard set of specifications would lead us to believe we can do so. Now, arguably, there may be some geotechnical factors that we haven't considered, but at least you've raised the question and got that engineer to relook at his design. It also provides us with tools to establish a better baseline estimate. As I said before, oftentimes I can pull up a standard specification, figure out what is needed materials, save me from having to go and solicit pricing from various vendors, and put together a high-level budgetary cost. As a client, that's huge. I get 4 or 5 phone calls a day. How much is a 60-foot bridge going to cost me? How much is so-and-so going to cost me? Here's what I'm thinking. Here's what I want to do. And these are the tools I use to put together that high-level baseline estimate. As consultants and designers, what does this standard specification do for us? Without a doubt, it reduces the time and therefore the cost in design work. For those who do work in BC, I don't know how many times you've seen. I mean, myself, I have seen just a reproduced standard set, almost to the point where the X, Y, Z values are whited out and the engineer's just penned in his normal values to save on design time. What it also does is it translates the industry language to a layman's terms. It gets everyone speaking the same bridge language around what's needed. It simplifies it down to the rudimentary level of what actually goes into the bridge. And this, of course, creates transparency from the client to the consultant all the way down to the contractor. And there's hugely implied benefits to having this. As an industry, what does this do for us? It raises the bar for industry standards without adding complexities. You go back to the title of this presentation, driving a cultural shift. We need to essentially beat out the old adage or the old way of thinking of whatever it takes to get a crossing in there. We need to rid ourselves of that. I mean, there's too many crossings out there that are makeshift bridge construction. There's too many rail cars, I mean, as a prime example, used in infrastructure in today's day and age. With this framework in mind, with this baseline design in place and at the forefront of everyone's mind, it shifts you from having to think about what do I have to what should I have or what should I need. And of course, there's cost implications to this, but if this industry is going to evolve and continue to be at the forefront of environmental infrastructure upgrades, I mean, that's the direction we want to see this go. The second point kind of plays into my first. I've touched on already. What the standard specification does is it attempts to remove the make it work mentality, the band-aid. Go back to that previous picture of a redeck job because that's what the pocketbook allowed for. Long-term reduction of construction design and maintenance costs. If this becomes, if we as a collective can come up with these standard specifications, this standard design that we all, in a sense, understand to one level or another, I would argue that there is a long-term reduction in cost. Doing things the right way the first time, I mean, again, as trite as that may sound, doing things the right way the first time, the maintenance costs experienced down the line are significantly less. Again, going back to that example of the maintenance of the wear deck replacement, that owner of that asset's going to replace that wear deck several more times, I'm sure, in his career. Not to mention what other issues may arise with that structure, which is obviously compromised. If he would have just had access to this, I don't know how many pages we'll call it, 20 pages, 40 pages of standard specifications, it's not that daunting. The design work is there. Maybe you put off that redeck for another year and then pocket the cash and go for a full-blown repair, which is going to extend your life expectancy of your bridge and reduce your maintenance costs further on down the line. So what's next? What's next for me? What's next for the consultants? What's next for the clients of infrastructure assets in Alberta? I mean, the short term, what I really see working, and I know this can be applied kind of in that northern Alberta region because I work closely with a lot of stakeholders, clients up there. We establish a standard set of specifications at the regional level, oil and gas, the forestry, and perhaps we roll this into the road use agreements. If anyone's replacing a structure, this is the standard that we're held to. Potentially get some engineer buy-in on this and push this thing forward. Long term, I know it does take some time to change these standard specifications. If you go back to the title page of the Ministry of Forest standard set of specifications, I think it was dated 1999. There's been some talk of some change. I'm sure there's been some amendments to that. I do know the designs are updated every so often. To actually change this thing at the provincial level is going to take some time, but there's no reason why we, as industry professionals in this northern Alberta region, we've already have the initiatives in place, of course, with this AWC3 Alberta Watercourse costing. A lot of the focus or a lot of the attendees, a lot of the people who are active within this are in that northern region. That's where I would start the conversation. These are the people who are pushing for a change, pushing for innovation in the industry, and that's honestly where I believe it starts. Nothing further to add. In BC, it is lunchtime. I know you guys are just coming off lunch. If not, some of you are probably already asleep, but that rounds out the conversation for today on adopting a standard set of standard specifications at the resource. Look how that's wordy. Anyways, thank you for joining me. Thanks again to Daniel and Bruce for taking the time and reaching out and getting me involved in this. I do appreciate it. I do appreciate being a part of this. And I've got a long career ahead of me, so hopefully this isn't the last time.
Thanks, Cody. Yeah, so we'll move on to a question and answer period. So if anybody does have questions, feel free to submit those through the toolbar on the right-hand side of your screen. Just to give everyone a couple of minutes to get their questions in because I'm not seeing any just yet. I'm going to put up a quick poll. So that should be on your screen now. I'll leave it up for about a minute. So this is just something that we do with every webinar, just to get an idea of who is attending these and who's participating. To let everybody know, we will be distributing a recording of the webinar, as well as a transcript of the Q&A portion. So if you have any questions, please submit them. If we don't have time to get to all the questions today, they will be answered in that transcript and they'll be distributed to everyone who attends via email. I know some people have been asking about them because we haven't actually gotten any out yet, but you can expect those soon. So we'll give this another 20 seconds. All right, we'll close that. So it looks like most people are from industry, which is not surprising, and consulting. All right, so let's jump into these questions. So the first one that we have here is, do you have any knowledge of the province of Alberta moving towards a set of standard specs for bridges for bush or resource roads?
Not to say that it's correct, but not to my knowledge. In Alberta, I deal primarily at the oil and gas level and the private forestry level. Anytime I am involved in rural Alberta infrastructure, it is more or less held to that Alberta standard specification. Even though it may be a low volume road, it is at the end of the day civilian or vehicle traffic expected in abundance. So no, not to my knowledge, but that's not to say that's not correct. I don't know what's happening behind the scenes at the provincial level. I could only speak to it at a privatized level.
All right, thanks. So is the development of such a set of standards best developed or initiated by industry industry and contractors, or is it better developed by GOA and in conjunction with GOA?
I guess it depends on who you ask. Myself as a contractor, and humility would probably help here, but I'm going to tell you that the contractor usually knows what's best applied. That's not to say that the government of Alberta doesn't listen. It's not to say that the government of Alberta doesn't have some very, very smart people within on the engineering level. But at the end of the day, I think you got to talk to the people who eat and breathe it every day. You got to talk to the Steve Acorns of the world, the Lynn Bergerons of the world, the people whose sole focus day in and day out is improving infrastructure on their roads. What has worked for them for the past 10 years or throughout the entirety of their career? That's where it's got to start. Those are the people who's got to build the framework. Once the framework's in place, then yes, of course, we'd absolutely bring in government of Alberta, bring in the consultants hired by the government of Alberta to further establish this and roll it out to the public. But at the preliminary stages, I strongly believe it's for it to be truly effective, truly cost effective. It should be done at the industry level.
All right, great. So next question here. Do you prefer to be the prime contractor and manage environmental and engineering professionals on site?
Sean Beatty, CNRL, thanks for tuning in. I prefer to be the prime contractor. And I do prefer to control the engineering, simply because all too often there's a sense of bravado here when the engineer comes in and myself as a contractor comes in and says, well, we can do it this way, this way, this way, save this much money. And the engineer says, well, where's your pinky ring? I'm the one that knows. And I guess I didn't put that lightly, but that's too often the case. As far as environmental goes, whether hired by myself or the client, it doesn't matter so much. What is important is getting the environmental person aligned with the contractor. And that's not to say that the contractor can just freelance off and do whatever he wants and say, okay, we need to get this done. That's priority one. A job goes so much smoother when the EM on site knows what the contractor is doing and how the contractor is doing that work. So whether that's hired by the contractor or hired by the client, it doesn't matter so much. But for the most part, yes, preference in being the prime contractor on the site. And there's a safety standpoint there as well. I mean, I would much rather control my own guys who are adjusted, who are trained under our safety policies, who understand our safety expectations, rather than bounce from job to job to job, where a new client has their own safety procedures and protocols in place. I hope that answers the question.
I think it does. Thank you. So what are your thoughts on modular prefab type bridges like Acro? Do you think these types of structures help address the resource gaps?
I'm horribly biased when it comes to temporary portable resource bridges, because we at SureSpan fabricate something seemingly a little different. And I know Sean, Steve Acorn, Lynn can all attest to that. But as far as portable bridges in themselves, there's a huge benefit to using them in industry. Yeah, going back to my original comments about a quick Band-Aid, a quick redeck, what we're seeing by and large for the pipeline work that's going on in BC right now is there's a lot of failing infrastructure. No one's committed to upgrade that infrastructure. That's not to say that's right or wrong, but what we see is contractors, pipeline contractors, general contractors, pipeline owners themselves are bringing in these resource bridges and overspanning existing failing infrastructure. The environmental impact benefits recognized up front is you're not going in there disturbing anything, you're not tearing out the existing structure. If it is failing, of course, then yes, some additional remediation has to be done. To further on this comment, the temporary bridge that's used in BC, that is the standard specification in BC, and I say temporary bridge lightly because I have seen these structures installed for upwards of 30 years. We're going out there assessing bridge sites and they got tags on them from 1970s. Widely used. From a fabrication standpoint, I know we fabricated around 270 of them last year, supplied to industry, predominantly in BC. I have yet to see the same interest in Alberta, the same kind of favoritism towards these portable bridges. The oil and gas industry, for whatever reason, has always erred to the side of oil field portable bridges, or your conventional steel girder, steel frame timber deck. But what we have seen, and what is nice to see, is those Alberta pipeline contractors that are now coming over to BC doing the work here today, Trans Mountain Pipeline, Coastal GasLink, have adopted this steel deck portable bridge, this modular bridge, and using it in every application possible. Huge benefit to the industry. Not used enough, in my opinion. That's all I got.
All right, thanks. So moving on to the next question here. What do you feel about using seconds for lock block footings? Seconds being the concrete pour from leftover volume of concrete.
I mean, it depends. You could always get an MPA test on that concrete block. You can always take a core sample. If the block's good, the block's good, regardless of whether it's leftover concrete from another pour or not. What I don't agree with is second, third, fourth use lock blocks used in infrastructure, unless, of course, they've gone through rigorous inspection and they are deemed acceptable. To me, that is in itself a Band-Aid. Again, much like that decking example I used previous. I have yet to see, I see very few lock block abutments in the Alberta resource sector when it comes to bridges. That's not to say they don't work, but in my experience, the foundations usually don't allow for such a use. There's far better applications out there. To me, a lock block is a temporary fix. It's a temporary abutment. So to your point, Clayton, if this was a 2-3 month bridge, temporary bridge, by all means, second pour block might be acceptable. If we are going to use lock blocks on a permanent foundation, if the site does in fact call for it, then I think as industry, we should be managing best practices and using new infrastructure.
All right, thanks. The next question, can you identify the top 3 or more reasons for resource bridge crossing failures in Northern Alberta?
Number one, first and foremost, would be improper installation or improper practice or improper design from the get-go. We're seeing a lot of infrastructure from 30 years ago, that old mindset, that old mentality of that rail car design, get across the creek and worry about what's ahead. A bridge is a necessary evil, or was a necessary evil 30 years ago. I mean, I'm sure a lot of people today still think that it is. But that's where we see the failure come into light, is just improperly built, sometimes even 20 years ago. A bridge in today's day and age, it's designed for 30, 45-year life expectancy. To say we've gotten that far with a lot of infrastructure that's in place right now in Northern Alberta is I think, surprising. Secondly, I mean, there's the obvious one, flooding, natural resources. And again, that ties back into improper design. I'm sure there's some hydrotechnical guys on here who can speak to improper Q100s, Q200s, or inadequate design on flows. You know, we see a lot of washouts. So it's a big failure. Not so much as the other two, but neglect. A lot of old, dilapidated infrastructure that's just outright neglected. If not maintained, if not replaced on a regular maintenance schedule, and of course you're going to see failure. I mean, the bridges in the Alberta resource sector are subject to a hard life. I would even argue a much harder life than that of BC. Track machines, cork machines, salt, calcium, mud, freeze thaw. Tough life for a bridge in Northern Alberta. So to reiterate, improper design from the get-go. Forget what my second one was, and environmental factors, I guess, would be my third. And Daniel or Bruce, you could go back to your notes and figure out what my second one was. That'd be great.
All right, thanks for that. I don't see any more questions coming in. So we'll give everyone another couple of minutes. If you do have any questions, please submit them. We do have, oh, someone just wrote in, the second one was flooding. That was your second.
So that's environmental again, I can carry over.
Yeah. Yeah, so I guess we'll wrap things up. We do have 15 minutes left, so if anyone does have any questions still, we can get to those. Someone's asking for contact info. Is it on the screen? No, it's not.
Should be on that last page of the slide there.
I'm not sure you're still sharing the screen.
How about now?
I'm not seeing anything.
You guys see that?
Oh, there it is. Now it's up. All right, so I think everyone should be able to see that now. All right, well, we don't have any more questions, so we'll wrap things up. I'd like to thank today's presenter, Cody Ponting. Thank you to everyone who attended the webinar, and we hope that you will join us for some of the other presentations over the next couple of weeks. Our next webinar in the series will be taking place next Tuesday, June 16th, and it will be about a collaborative approach to watercourse crossing restoration during area-based closures. So if you enjoyed this webinar, I encourage you to have a look at the other webinars scheduled as part of the series on our GoToWebinar page or on the awccc.ca website, and register for some of those other presentations. Thank you again to Cody for presenting to us today, and I hope to see all of you attending some of our future webinars. So stay safe and have a great day.